Welcome to Cisco's 802.11n technology demo. What we'll be looking at today is a series of applications and how they interact with the new 802.11n bandwidth. First, an introduction to what we're looking at. This is a Dell Precision laptop with Intel's 4965 AGN wireless card built into it. Nice thing about the Dell is it has 3 discrete antennas, so we can take advantage of the multi-spatial stream capabilities of 802.11n. Down here is an application called Bandwidth Meter Pro. What this allows us to do is visually see the throughput capabilities of the traffic. Here we can see a previous run, or you can see the maximum and minimums of the throughput. We'll go ahead and monitor that as we run the demo. Over here we have the Intel ProSet wireless control panel. This allows us to switch between the different SSIDs we have set up. Now, as far as what we'll be doing today, we have 2 SSIDs that we're using. The 1240A SSID is the non-11N SSID that's coming out of our 1240 access point. The 1250-AN SSID is the SSID coming out of the 1250 that has 11N speeds enabled. Now, we're both using the same frequency, 802.11a in the 5 GHz space for the purpose of the demo. Now you'll notice, I'll go ahead and double click on the 1250AN. The Intel ProSet wireless client shows that we're connected at 300 megabits per second, so you can see that we have wide channels enabled. Let's go ahead and take a look and see what 802.11n can do. First application we'll be taking a look at is something called iPerf. This is a performance blaster application that's been around for a long time, public domain, and we have a 30-second script that's blasting out 6 streams of UDP traffic. Now we can see, taking a look down here, we're running at around 203 megabits per second, and you can see the bandwidth visualization up here on the chart. So very impressive right out of the start. You can see that there's a significant bandwidth capabilities built into 802.11n, actually running around 210, 217 megabits per second now. The script runs for about 30 seconds. On the other side of the wireless network is a server that's hooked into a gigabit Ethernet port running the iPerf server. Now let's go ahead and switch to the 1240A SSID. Remember, this is the SSID that does not have 802.11n enabled. We'll go ahead and run that same traffic blaster script again. You can see we kick off 6 streams. Now the reason we're kicking off 6 streams is that we're trying to get the maximum throughput that we can through the wireless network. Now we'll notice Bandwidth Meter Pro is showing around 27, 28 megabits per second. Now it's interesting, you see a huge difference, 200, 210 versus 28 megabits per second, roughly a 7 times increase. So very, very fast from a performance standpoint with 802.11n. The next thing we're going to show is an FTP application. So instead of using UDP, we'll go ahead and see what the performance looks like with FTP. We'll launch our FTP client, and again on the server on the other side we have an FTP server sitting there. Go ahead and clean this window up a little bit so it looks nicer. Now I've got a 100 megabit file on the client. I'm going to drag this over and drop it on the server. Go ahead and replace the one that's out there. You can see it's going to take around 30 to 40 seconds to copy this over. Let's let it do its thing. While it's copying, we can take a look at the Bandwidth Meter Pro. Here we can see we're running around, 17 to 24 megabits per second variable rate. You'll notice that the FTP application still has around 20 seconds left. And even though while we did the UDP traffic we were getting around 28, by using the FTP protocol with the overhead of the connection, we're only getting around 19, 22 megabits per second out of this. Now you can imagine this is a 100 megabit file. It's fairly quick, but in the purpose of a demo it's probably a long 30 seconds. You can imagine though if this was a much larger file it would take a significantly larger time. Now let's go ahead and switch over to the 802.11n SSID. Again, we can see we're connected at 300 megabits per second using wide channels, and let's do the same file copy operation. We'll drag the local file over to the FTP server, go ahead and replace it. Now once it gets started, we only have around, you can see, 4 seconds left. You can see bandwidth wise we're running at around 120 megabits per second before I even know it, the connection's done. Again, FTP traffic running at around 120, UDP traffic was running around 210. So definitely, you're seeing the effects of the TCP connections. You'll also notice too, file takes much faster to transmit. this took 40 seconds, this took about 5 seconds. So from a time on the wire standpoint, you're actually seeing much better performance, much more room for other type of application traffic. Let's go ahead and close our FTP client. Last thing we'll do is take a look at an HD video being pulled over 802.11n. Now while this loads up, you can see we're still connected 802.11n speeds. Move this window down to full size, shrink the screen up so we can see the rest of the tools. Now you'll notice from a movie standpoint, what we're taking a look at here is a full HD movie. It's encoded at 1920 by 1080 pixels, and it's actually a 1080i video stream, encoded at around 60 frames per second. Now let's go ahead and play this and take a look, and keep an eye on the Bandwidth Meter Pro so we can see what's happening. You can see we're pulling in around between 20 and 30 megabits per second. Variable bit rate based on the encoding capabilities. It's going to be pumping more data when more pixels are changing on the screen.
Columbus weighs anchor from its port in Florida. Atlantis on the proper alignment, heads down, wings level for the 8.5-minute ride to orbit.
You can see smooth graphics.
Space Station for docking on Saturday. 28 seconds into the flight. The 3 liquid fuel main engines soon will throttle back to 72% of rated performance, going in the bucket, reducing the stress on the shuttle as it breaks through the sound barrier.
Now you'll notice here we've got quite a variable bit rate depending on how many pixels are changing on the screen, and that's really what encoded video looks like. Well, let's go ahead and switch to the non-802.11n SSID. We're now running at 54 megabits per second. We'll go ahead and play that video again and see what happens. You can see we're pulling around 16 to 18 megabits per second. And it's quickly obvious that the video and the audio is having a hard time keeping up. Here we can see we completely dropped out. But you'll notice we're maxing out pretty much as we can the throughput capabilities. And you can see the video just can't keep up, the HD stream can't keep up with the bandwidth given to it. Let's go ahead and pause that. I think you get the idea of why this wasn't playing. And again, take a look at the difference. Here we're looking at the HD stream pulling between 20 and 30 megabits per second, and without 802.11n we're really capped out at about 18 megabits per second. Now what you can see here really is the difference that 802.11n gives you. It's interesting to note on the HD stream we're using nowhere near the bandwidth capabilities of N, yet it gives us enough overhead to get the video through. You can imagine now you can have a network that's got videos, FTP, other type of traffics, and there's a much bigger pipe to get all the data across. So it's really allowing your applications the bandwidth they need to perform as expected. So that concludes the demo today. Hope you enjoyed watching the power of 802.11n.